Hey guys, so the problem that we'll be discussing today is from the recent October Lunchtime 2021, and the problem name is exactly n plus 1 values. So the difficulty level of this problem is easy and its prerequisites are some observation. Now let's read the problem statement. So the problem statement says that you are given a positive integer n. Now you have to print exactly n plus 1 positive integers satisfying the following conditions. Now what are the conditions? Exactly one value should appear twice and all the remaining values should appear only once. So basically we are going to have a total number of n unique numbers and only one of them will be repeating. Okay, so let's and the second condition is that the sum of all these values should be equal to 2 to the power n. Okay, so basically if we have n plus 1 values, they are going to be something like this: a1 plus a2 plus a3 up to an. So these are n plus 1 values, right? And their sum will be 2 to the power n. So basically this is what we are told to do. So now what we have to do is we have to print these values in non-decreasing order, okay? And if there are multiple solutions, we can print any of them. Yeah, so let's take an example quickly. So maybe n is equal to 3. Okay, so what is 2 to the power n over here? So 2 to the power n is the sum that we want to achieve, right? So 2 to the power n is 8. So now can you think of 4 such values? So we have to print n plus 1 values, right? And since n is equal to 3, we have to print 4 values. So the 4 values can be 1, 1, and say what? 4, what remains? 2. So 1, 1, 4, 2. These are the 4 values. 4 plus 2 is 6, 1 plus 1 plus 1 is equal to 8, right? So this is a valid answer in this case. So yeah, this was a sample case. Now let us quickly proceed to the solution approach. So let's start discussing the solution. So when we look at this, what idea first comes to our mind? So that what we have to do, 2 to the power n should be represented like a1 plus a2 plus a3 up to plus an. So what we will try to do is, if we keep a1 is equal to 1, right, then a1 plus a1, so this will be something like 2 plus the other numbers. So now one thing we can definitely say that if we take, so these are n minus 1 numbers, right? So if we consider that we are only going to take even numbers for these numbers, then we can definitely make an even number, because 2 to the power n is definitely going to be even. Now 2 to the power n minus 2 will also be even, right? So if we take these numbers, so this is definitely going to be even, right? So we can always take these numbers as even. Now what are the best even numbers that we can use over here? So let's think in another way. So here we have taken a1 to be 1, right? So now let's take a1 on this side. So now what we have is 2 to the power n minus 1 is equal to a1 plus a2 plus a3 up to an. And here we have taken a1 to be 1, right? So basically this is nothing but 1 plus a2 plus a3 up to an. Okay, so now what we are going to do is we are going to try and write this in its binary representation. So now in general, if you speak, if I give you a number of the form 2 to the power n, so what will be its binary representation? Yeah, it's very easy. It's going to be all ones. So just to check out quickly, if n was equal to 4, then 16 minus 1. So 16 minus 1 is 15. And what is the binary representation of 15? It is nothing but 1, 1, 1, 1. Right? So 8 plus 4 plus 2 plus 1. This is binary representation. Now, looking at the binary representation, do you get any idea of how we can do this? So it's now very obvious from the binary representation that if we have 2 to the power n minus 1, okay, so let's discuss for 16 first. So for 16 minus 1, here we would have 1 plus a2 plus a3 plus a4, right, as n was equal to 4. Now let us use the binary representation of 15 to fill these numbers. So what it would become? It would become 1 plus 2 plus 4 plus 8, right? And obviously once we bring this one over to this side, we can represent 16 as 1 plus 1 plus 2 plus 4 plus 8. So I think this is a fact that we learned in school, that the sum of all continuous powers of 2 starting from the first, so basically 1 plus 2 plus 4 plus 8 up to say 2 to the power n minus 1 is nothing but what? 2 to the power n minus 1, right? So this is we had learned this in school, right? So we can just verify it quickly. So here let's take n is equal to 5. So we have 1 plus 2 plus 4 plus 8 plus 16. So what is the sum over here? It is nothing but 31. And if n was 5, then 2 to the power 5 minus 1, it is again 31. So this is proved. Hence what we have to do, our final answer. So let's say our final answer is nothing but print 2 ones. So just print a 1 first and then print all the powers of 2 up to n minus 1, right? So here we have n, and what we have to do is we have to print 2, 4 up to 2 to the power n minus 1. So this is our final answer. And here we have 1, 2, and we have to repeat the 1 obviously, so as to satisfy our condition and also our sum. So yeah, this was the solution. Now let us quickly go to the implementation. So for the implementation part, I will be discussing C++ implementation and also Python implementation. So let's go. So starting with the implementation, first we take input t, number of test cases. Then we take input n, which is the given number. Now what we are going to do, we are simply going to output the first one over here. That is the extra one that needs to be outputted. And now what we are going to do, we are just going to run a loop from I is equal to 0 to I less than n. That means the last value of I will be n minus 1. And we are just going to output the power of 2 to the power of I. So here we will be using this left shift operator. And remember over here, you have to write 1LL. So this is a very common mistake that you may make. So 1LL is important because since we have n less than equal to 60, the value of this can go into long int, and therefore writing 1LL is important over here. So if you miss this, you will get a wrong answer. Okay. So yeah. So cout 1LL left shift I. And that's it. That's the question done. This will give you a AC 100%. So now let's switch to the Python implementation. So for Python, we again do the same thing. We take input t, number of test cases, then in the range t, then we take input n, which is the number given to us. Again, we first print the single one over here, and now we will again print the powers of 2 for every value of I from 0 to n minus 1. So print 2 to the power I and end with space. And lastly, we'll print an empty line over here so as to switch to the next test case. Okay. So this is the Python implementation. Now let us try and submit this and see if we get an AC. So submitting. Yeah, so we got an AC. This is the end of the video. I hope you liked it, and if you have any doubts, feel free to leave them in the comments. Thank you.